we're going to do a cyanogen bromide mechanism from the fall 19 test 4 exam. You'll be given a question like this on your exam up here. I stole this from the updated mechanism notes that we have available online. You won't be given those during the test. But here we go. What's your first goal? Well, your first goal, I guess, if we can use this as a guide, you need to keep the methionine group, the amino terminal nitrogen, and the amide here, and we can do our circles to be similar to those. So circling everything except for the NH after the methionine. So this piece, little piece, is R. And over here, everything before the NH of the methionine is R prime. And the sulfur, it attacks cyanogen bromide in the mechanism first. Red first. Blue second, and if we need a third color, it's anything that's not red or blue. And red first, attack cyanide. Nitrogen's a little more electronegative than bromine, that's why the electrons go there first. Nitrogen has a lone pair which can come back and eliminates Br minus, because that's exactly what's happening. You get your triple bond back, Br minus, bye-bye. And it looks like ChemDraw is to blame for this typo on our updated mechanism, but you know, I'm not even going to grade Br minus, it's just a leaving group. That mechanism doesn't create HBr, right? That creates Br minus. So it had HBr there because sometimes ChemDraw fills in things if I don't have a charge there. Anyway, you don't need to know that. TMI. We got R prime. R prime attached to an NH, attached to a carbon. It goes to a carbonyl that has an NH. You never know when you're going to have to draw those H's off there. And that's an R. And moving our guide down. CH2 once, twice to a sulfur that has methyl on one side and a cyanide on the other. Cyanide turns you purple. Well, more TMI, sorry. Okay. What do we got going on now? We're here. Oh, sulfur has 3 bonds though. Oh my. Don't be throwing half points away. 3 bonds, just like oxygen. Hey, now it's a good leaving group. That's basically what you just did. You made sulfur into a better leaving group. And you're going to make it leave by attacking it with the carbonyl oxygen that became a nucleophile when nitrogen resonated with it. See how I said that? The resonating nitrogen lone pair, that does not look like a lone pair, resonates in, makes a double bond. Pi attacks the carbon that is the sulfur, that has the sulfur, and sulfur leaves. You get a ring. You get a ring. Let's just draw from where I had it. R is attached to N, it's attached to H, to carbon, bonded to a carbon. I'm gonna go the O down, double NH up. Because the O is now part of a ring that goes to CH2 once, twice, back up to the alpha carbon. And you can also say, I don't know, you don't have to do this at all, but there it is. You got that molecule at the same time. It's hydrolysis time and we're done. That's it. This just needs to become a carbonyl, and you have this. Water's your nucleophile for hydrolysis. I think that's self-explanatory. Water's the nucleophile for hydrolysis. Let's just do it. OH2. Oh, it looks like we might be able to combine a couple steps and get done faster rather than slower. And water's going to be used a second time as a base. So here's how the hydrolysis rolls. You got kind of an activated nitrogen up there. Attack the carbonyl. Can't do a two-stepper here in one. Can't do it. There's no lone pair on the nitrogen. So you got to do this step all by itself. But you can neutralize the O. So you are combining that step. Neutralize the oxonium and draw what you get, which is going to look a lot like this. But we'll draw from Mars. H, N, R comes to a carbon that has an O, CH2, CH2, and HR prime. You know, I could have done a better circle. I could have had NH in the circle, couldn't I? It's okay. And we have an OH on there that's new. You're here. And we have a hydronium from before we can use as an acid. We made a hydronium in this step. And the base and if you want to, I mean, I said this is a new and improved mechanism, but we could improve it even some more. No, we can't. It's perfect. It protonates the nitrogen first. I didn't know it was broken down to steps. Sorry. Protonate nitrogen first. Why? To make it a better leaving group. Then do the elimination. Once you have a good leaving group, you can do elimination. And that gives us our other two products. You get this thing here and the big guy here. And there's your cyanogen bromide mechanism. Big picture. And it looks like when I moved stuff, that little correction here got moved too. There we go. And we're done.